Welcome back with another video on TryHackMe.com. This is Zahinazi and we are doing on-premises IaC, which is part of infrastructure as a code module, and we are doing it on TryHackMe, but we are following DevSecOps learning path here. We'll be able to complete on 31st July 2024. They are saying we are a bit behind. I don't know why, because we have just 2 rooms left. So in this video, we're gonna start the on-premises IaC. This room provides security guidance for on-premises infrastructure as a code. Let's get into it. Okay, so on-premises IaC, it have medium difficulty. I think this is the first one or second one which have medium difficulty on this path, and it will take 120 minutes. That means at least 2 or 3 videos on this path. Okay. So what I'm gonna do is I'm gonna start the attack box at least, okay? Because once we reach to the task 4-5, we're gonna do that anyway. So I'm gonna give it a minimize, and once I split it again, it will be available. Okay, so I'm gonna minimize it, and let's go to the theory itself. For task 1, introduction. This room we will learn about on-premises infrastructure as code, IaC deployment. While this may seem outdated in a cloud-based world, some good reason exists for doing on-premises instead of cloud deployment, especially in heavily regulated industries. From my experience, as a solution architect, I can tell you that if you are in highly regulated industry or in a government side, going to the public cloud is out of the question, okay? Because of the sensitive data and regulations and all the things that we need to comply, okay? So even you are able to trick them with the IP addresses and all these things, they will still be able to point out within the audit report that which services should be on premises and whatnot. Okay, so considering that there is even though cloud deployment is available, I mean the public cloud space is available for all other solutions, but in heavily regulated industries, still we need to deploy on premises. Okay, so on premises may mean that, okay, maybe it is from Microsoft, like the Azure data center, but it is private data center, so we still say it is on premises, okay, because it is not available to the public itself. This is a nice graphic I can see here. As you can see, we are moving the weight from one building to other building, and we are working on it. Okay, so information is coming from up and it is going through the data center. Awesome. Prerequisite: basic offensive security techniques and skills. We have it, but we did not cover in this DevSecOps learning path. But let's see what we can do. Intro to IaC. I already have a room for IaC. Just look that in the playlist, and I will also put a flag in the video here as well. You can see the code either here or either there. Okay. Learning objectives: understand the reasons for on-premises IaC. Okay, you will understand that understand the benefits and drawbacks of on-premises IaC. Understand and know how to use Vagrant. All right. Understand and how to use Ansible. We know about all these tools, and we heard about them, but not. We don't have any practical experience in these tools. Okay, as per the learning path we are following. Understand the security concern for Ansible and Vagrant. Okay, so this room contains a non-guided challenge in task 7. You will have to use knowledge learned in this room together with basic offensive security skills to complete this challenge. So we'll do our best. Okay, I will guide you through the process. Okay, let's go to the task 2. All right. Why on-premises? On-premises IaC refers to using infrastructure as a code to deploy systems and services on an internal network. In essence, all the infrastructure that will host the systems and services can be found locally in the organization data center only. Reasons for on-premises IaC: In the modern world where we have several cloud providers using on-premises IaC may seem counterintuitive. However, there are some cases where on-premises IaC will suit your needs much better. The biggest benefit is that it allows you much better control of your entire IaC pipeline. Let's use another popular example: GitHub versus self-hosted GitLab. Okay, so we saw this example in this learning path, and we know and understand the context here. As a case study, GitHub and GitLab are two popular source code management platforms backed by the popular versioning software Git that are used by organizations. However, deciding between the two often becomes a question of control. If you self-host the solution using GitLab is created by Ukrainian developers, and GitLab was the first software that reached to $1 billion benchmark within the Ukraine. I mean, that originated from the Ukraine, not within. They originated from the Ukraine, but they were selling the solution to customers globally. You fully control the entire stack. You can ultimately not only responsible for the management of the GitLab platform, but also underlying infrastructure. While this is a lot more work, it also allows you to lock down access significantly. For example, you could only allow access to your GitLab instance via VPN, okay, within the network itself, meaning it is not exposed to the internet for everyone. Awesome. Conversely, using GitLab means you are shifting some of that security responsibility. It is important to remember that GitHub is a software as a service SaaS solution. GitHub is a software as a service solution. That means that if you use GitHub, you have no control over the infrastructure hosting your source code. Instead, you are transferring the security responsibility of the infrastructure management to GitHub, which becomes a third party of your organization. While these organizations take security measures seriously, their security is not without flaws, which can leave your organization's source code exposed. This is a risk that you have to accept whenever you use a third party. Okay. So this is, where supply chain solutions come into the place. This is basically a supply chain, right? So you are dependent on GitHub to store your source code and do all the automation that you need to do. And they will do, pretty good security management, but still the security that your organization require may not be the same which GitHub is targeting. So it may expose you to some kind of risk. Okay, you can click on the expose to see the news, which is coming from the hackernews.com. Extrapolating from this case study, you should see why some organizations still prefer on-premises IaC, especially in heavily regulated sectors such as financial or government sector. Yes, this is very true. While on-premises IaC is definitely more effort, it provides an organization with full control and customization of their IaC pipeline. Okay, so benefits and drawbacks. Okay, let's see what we have here. To summarize why one would use on-premises IaC and determine if it is the correct solution for your specific problem, let's look at the benefits and drawbacks. On-premises IaC has the following benefits. Allows full control of IaC pipeline. The IaC pipeline can be fully customized for your exact needs. Data protection and regulation is easier to perform as the IaC pipeline does not host resources on third-party systems. Everything will be on premises. While the initial investment cost of infrastructure is high, yes, there are no monthly fee for hosting the IaC pipeline. That is very correct. It is often easier to do small deployments. Yes, even big deployments in nowadays environments. On-premises IaC has the following drawbacks. As you are hosting your own IaC pipeline, you are fully responsible for its security and configuration. Scalability of deployments is not as flexible as cloud-based IaC, which can lead to either not having sufficient resources for the deployment or an over-investment in resources. Okay. The initial investment for on-premises IaC is significantly higher than the cloud IaC. That is very true. So they are saying that since it is on-premises, there is a lot more responsibility in the security and configuration. The scalability could be a challenge if the resources are not enough, or you could also have the risk of over investment in the resources that you are not utilizing it. Okay, and then there is a initial investment cost is more than what we have on the cloud provider services. Okay. Now that you understand why on-premises IaC can be used, let's dive into some of the tooling that can be used to create your very own on-premises IaC. While there are many different tools and software that can be used, for this room we will focus on Vagrant and Ansible as examples. Awesome. Very good. Finally, we'll do some practical using these tools. If I want more control over my pipeline, should I use on-premises IaC? Yes, of course. This is not everybody want more control. If I want to have a flexible and easily scalable deployment, should I use an on-premises IaC? Easily scalable? No. If I have strict data protection regulation enforced on my organization, should I use on-premises IaC? Yes. If there is strict, then you need more control and you should use on-premises. Awesome. So we are 12 minutes into the video. Let's move on to the task 3, Vagrant basics. Okay. In our on-premises IaC journey, we will start with Vagrant. Vagrant is a software solution that can be used for building and maintaining portable virtual software development environments. In essence, Vagrant can be used to create resources from an IaC pipeline. You can think of Vagrant as the big brother of Docker. Okay. In the context of Vagrant, Docker would be seen as a provider, meaning that the Vagrant could be used to not only deploy Docker instances, but also the actual servers that would host them. Okay. So the Vagrant is a software solution that can be used to for building and maintaining the portable virtual software development environment. Okay. Terminology. Before diving into using Vagrant, let's brush up some terminology first. Okay. Your term and definition. Provider. A Vagrant provider is the virtualization technology that will be used to provision the IaC deployment. Vagrant can use different providers such as Docker, VirtualBox, VMware, and even AWS for cloud-based deployments. Okay, so it have got some kind of integration with all these providers. Okay, so they build their virtualization layer on top of it. Okay, so you create something in the Vagrant in just one interface, and this will be replicated either on Docker, VirtualBox, or VMware, depending on your underlying provider. Okay, provision. Provision is the term used to perform an action using Vagrant. This can be actions such as adding new files or running a script to configure the host created with Vagrant. So this is basically the provision of creating of the infrastructure itself. Configure is used to perform configuration changes using Vagrant. This can be changed by adding a network interface to a host or changing its host name. So after provisioning, after creating the infrastructure, you configure it. Okay, host name, which ports will be allowed, which port will not be. If you need to add one more interface, network interface or whatnot, these kind of things you will do with configure. Variable. A variable stores some value that will be used in the Vagrant deployment script. So it's kind of an environment variable kind of stuff where you store your secrets box. Box refers to the image that will be provisioned by the Vagrant. So box is the image that will be used to provision either a VM or container. Vagrant file. Vagrant file is provisioning file that will be read and executed by the Vagrant. So once you configure something before provision, you create a Vagrant file, and you can save this file to use it as a template to create further infrastructures. Vagrant example, let's take a look at a simple Vagrant provisioning script. In our example here, we have the following folder structure. So we have provision, then we have files.zip and script.sh, and then the Vagrant file. Okay, Vagrant file script has the following code. Okay, so this script.ch or the Vagrant file itself, the Vagrant file, I think itself, vagrant.configure do, and then cfg, I think is config vm define server do config.vm.box is this one. Box is the image, right? So the image that we need to provision. So this is Bionic 64, hostname is this one, and provider is VirtualBox. Then do this, which is override. We don't need our GUI, CPU is just 1 and memory is 4 GB. And then we are attaching a private network with the IP address like this, 72.168.2.101, and then we are again attaching another network which IP address is this one. Then we are defining server 2. This was server 1, this was server 2. Same thing, everything is same, but name is changed here. We are assigning CPUs 2 here and 4 GB RAM. Then uploading something here, config.vm provision file source, provision files.zip, destination is temp files.zip. Run the script, which is this one, provision shell, and then the script you will run. Okay, so pretty much straightforward here, nothing complex, just we are creating one VM here using VirtualBox provider. Okay, in this example we are going to provision 2 servers. Both of these servers will start with the base Ubuntu Bionic x64 image like Docker. These images will be pulled from a public image repo. We could, however, tell Vagrant where to find these images, meaning they can be pulled from a private repo of images as well. You can see that both servers are configured with a hostname and how many CPUs. This is 1 and RAM is 4 GB. Each host will have. The first server will also have 2 network interfaces with static IPs attached. The second server will have a file called files.zip uploaded and a script called script.sh will be executed on the host. So they are saying second server will have the file, but we already ended here. Okay, and for here, this one. Then we still use the config. And then we send the files here. Okay, now it is clear. But here we are creating 2 networks here, but here we don't have any network at all. Okay. If we want to provision the entire script, we would use the command vagrant up. This would provision both servers in the order specified in the Vagrant file. We could also decide to only provision one of the server by using the server name. For example, test server could be provisioned using Vagrant up server itself. If you want to play around with the VirtualBox provisioning with Vagrant, look at this repo. You can just look at this repo if you want. Using VirtualBox and Vagrant, this repo will allow you to create your very own Active Directory AD network with 2 domain controllers, a server and a workstation. Give the Vagrant file a read to see what provisioning will be performed on each host. We will create our very own IaC deployment script in a bit later in this room. Awesome. What is the name of the file that Vagrant uses for provisioning? It's a very simple one. It is Vagrant file. I think so, without an extension. What command can be used to provision all hosts with the Vagrant? Vagrant up. Vagrant up. Okay, so what command can be used to provision only the web server host with the Vagrant? So we have Vagrant up web server. Awesome. So we are moving towards Ansible basics. Let's cover the Ansible basics in this room, and once we come back, we'll cover tasks 5 and 6 and then 7 in the last video. Okay, let's move forward. Ansible basics. In the next IaC tool to learn about is Ansible. You can click on it to see the website itself. Like Vagrant, Ansible is another suite of software tools that allows you to perform IaC. Ansible is open source, making it a popular choice for IaC pipelines and deployment. One main difference between Ansible and Vagrant is that Ansible performs version control on the steps as executed. This is what we need. Okay. This means that the Ansible is similar to the Docker in that it will only perform updates on steps that require updates instead of requiring a full re-provision. Awesome. Terminology. Before diving into using Ansible, let's brush up on some terminology first. Term, definition, playbook. We have playbook, and Ansible playbook is a YAML file that with a series of steps that will be executed. Template. Ansible allows for the creation of the template files. These act as your base files, like a configuration file with placeholders for Ansible variables, which will then be injected into at runtime to create a final file that can be deployed to the host. Using Ansible variables means that you can change the value of the variable in a single location, and it will then propagate through to all placeholder in your configuration. So this is a template. Template will allow to create the template files, which will be used as base files, like a configuration file. And then there are some variables which will be injected into the runtime to create final file and can be deployed to the host. Ansible variables mean that value can be changed in a single location, and then all will be propagated through placeholder in the configuration. Now I understand all of this. Role. Ansible allows for creation of a collection of templates and instructions that then called roles. Okay. Roles. Okay. A host that will be provisioned can then be assigned one or more of these roles, executing the entire template for the host. Okay. This allows you to reuse the role definition with a single line of configuration, which you specify the role must be provisioned on a host. I'm not sure what does that mean, but maybe once we do the actual practice, we'll get to know. Maybe this is kind of like, okay, we provision a web, for example, a VM. So role could be either a web server or a database, or maybe a caching server or something like that. Okay. Now we have the variable. We saw already variable in the template definition. A variable stores some value that will be used in the Ansible deployment script. Ansible can take this a step further by having variable files where each file has different values for the same variables, and decision is then made at the runtime for which variable file will be used. So some could be like a dev stage or production kind of settings here. Okay, Ansible example. Ansible makes use of specific folder and file structure. The most important part of the structure is the playbook, a YAML file that ultimately dictates what commands will be executed for the provisioning. Let's take a look at the typical folder structure. So we have playbook which is the most important file, playbook.yaml. Then we have roles, common, default, main task is apt, main task 1, task 2, yum, template is template 1, template 2, then the variable, it is Debian, and this is Red Hat. Then we have roles 2, 3, 4, and then variables, and the var.yaml as well. Okay. The folder structure was only expanded for the common role. All right. However, this same structure would apply for the role 2 and 3. Okay. Got it. Well, let's dive a little bit into what each of these files would do. Let's start with the playbook.yaml file. All right. Configure the server. Host all, become yes, roles common, role 3, var file is variable, var.yaml. Okay, so this is what will be inside the playbook.yaml file itself. Okay, clear. As we can see, the playbook specifies that the common and role 3 roles should be applied for all hosts where this Ansible playbook will be executed. It will also use the var.yaml file to override any default variables within the roles. This allows us to only change the default variables where needed, as the defaults will then still be applied to all other variables. Okay. To execute the common role, Ansible will load the variables from the defaults main.yaml file and override this variable with any new values found in the var.yaml file. It will then read and execute the task main.yaml file. This file could look something like this. Okay, so this is the name. Include OS specific variables. Include wars item with the first found Ansible underscore distribution.yaml and Ansible OS family.yaml. Name set root. Okay, user name is root, password is coming from variables, I think. When root underscore password is defined, include apt.yaml when Ansible OS family is equal to Debian. Include yum.yaml when Ansible OS files is equal to Red Hat. Include task1.yaml and include task2. Okay, let's see the description of it. The first section of the Ansible file will determine the OS distribution of the host. So this is the first one. It will then use this information to include OS specific provisioning steps. As you can see from our folder structure, we have specific provisioning steps based on whether the distribution is Debian or Red Hat. The second section of the playbook will set the root user's password here. In the third section, we update the host and install some packages. However, we only execute the installing steps matching the OS distribution. If the host is Debian, we will execute the commands specified in apt.yaml file. If the host is Red Hat, we will execute the command specified in the yum.yaml file. This allows an Ansible role to be OS distribution agnostic. Lastly, we will execute the commands contained within the task1.yaml and task2.yaml files. This can be any command such as adding files to the host or making configuration changes. This is quite a lot of information to take in, but as you start using these tools and follow along with what scripts get executed when, it makes a lot of more sense. Yeah, this is what my usual suggestion is. I'm going to go through the theory itself, but once we will do the actual practical, all of these things will come into the light and you will be able to understand much more deeply. Combining Vagrant and Ansible. When you could stick to one IaC tool for your entire pipeline, it can often be beneficial to combine tooling. For example, Vagrant could be used for main deployment of the host, and Ansible can be used for host-specific configuration. This way, you only use Vagrant when you want to recreate the entire network from scratch, but can still use Ansible to make host-specific configuration changes until a full rebuild is required. So it's like you use the Vagrant to create all your infrastructure in one go, and then you use Ansible to manage or maintain this infrastructure. Okay, unless you need to create the infrastructure again from scratch, then you will go with the Vagrant again. So this is what they are trying to say here. Ansible would then run locally on each host to perform these configuration changes, while Vagrant will be executed from the hypervisor itself. In order to do this, you could add the following to your Vagrant file to tell the Vagrant to provision an Ansible playbook. So config VM provision, then the Ansible local do Ansible, Ansible.playbook is provision, playbook.yaml, and Ansible.become is equal to true. Okay. So there is some kind of integration already. It is also worth noting some of the differences between Vagrant and Ansible if you are looking to only stick to single IaC solution. Okay, so the Vagrant is configuration language is Ruby for Vagrant files. Ansible is YAML. YAML is pretty standard for everything nowadays. For playbooks, integration with other tools often used with the provisioning tool like Chef, Puppet, and Ansible can be used standalone or integrated with other CI/CD tools. Complexity, relatively straightforward for setting up deployment environment. Higher complexity for larger infrastructure and advanced configuration. Scalability, more suited for small scale individual deployment environment. Ansible is highly scalable, suitable for managing complex multi-tier application. Yeah, so the Ansible is the way to go. Execution model is procedural style with sequential execution steps. Declarative model describing the desired state of the system. Okay, so I'm more tends toward the Ansible. But you can still use the Vagrant, or maybe the for example, if you are using VMware, they have their own IaC tool. I think it's called Aria. You can use Aria to create all the infrastructure for you, and then you can use Ansible on top of it to configure your resources. Answer the questions below. What is the name given to the file that Ansible will provision? Playbook. Playbooks or book. Yay, okay. And we are on streak 23. Awesome. What is the name given to an Ansible file that will be updated through the injection of Ansible variables to create a final file during the provisioning process? Variable var.yaml. Here it is. So let me put it here. I'm not sure if this is the actual thing. Okay, through what is the name given to an Ansible file that will be updated through the injection of Ansible variables to create a final file during the provisioning process. What will be the file name? I'm not sure which one it will be. Maybe playbook.yaml itself. I'm not sure, guys. That is not okay. Let's go to the next one and then we'll find this one as well. What is the name given to an Ansible collection that can be provisioned with a single configuration request? Ansible collection. I'm not sure. So this is what we have. So the Ansible collection is role. Ansible collection is role. And we need to find a file. So variable store some values. File will be used. Decision is that then made a runtime for which the variable file will be used. I'm not sure which one I need to put here. Just a moment, guys. Okay, so it was template itself. I mean, the question is a little bit confusing, right? they are saying Ansible file. So basically it's just a template itself. Okay, we have playbook, we have template, and then we have role. Awesome. Do we have template anything here? We don't have. Oh yeah, we have the template itself here. Okay, so that was the file itself. So we are good. Once we come back, we'll do the task 5 and 6, and in the next video after that we'll do the task 7 and 8. Thank you very much for joining me on this journey, guys. If you like the video, please give it a thumbs up. If you haven't subscribed, please subscribe and share this video with others, so I will create a vibrant community around DevSecOps. Okay, and thank you very much. I will see you in the next video. Bye.